Most people assume that AI remembers everything, every conversation, every question, every command, but is that really true? On this episode of Today in Tech, we're exploring the ideas of how machines remember, why they forget, and how this will change as AI evolves from chatbots to full-fledged digital agents. Hi, everybody. Welcome to Today in Tech. I'm Keith Shaw. Joining me on the show today is Jacob Buckman. He is the co-founder and CEO of Manifest AI. Welcome to the show, Jacob.
Thanks so much for having me, Keith.
All right, so let's start with the basics because I think a lot of people have assumptions about what AI quote unquote remembers. Some of it is true, but there are some things that might be more myth than reality. So, what assumptions do people have that are taught when they talk to you about an AI tool remembering previous interactions? Kind of what's true and what are the myths out there?
I think a very common and understandable thing for people to do when communicating with AI is to assume that it's going to behave just like a person. And in many ways, it is. The responses you're getting back from it will often sound very similar to things that a human might say in that situation. But there's other ways that are maybe less visible where it's very, very different. And memory, as you mentioned, is very much one of these places. So in general, if you're having a conversation with a chatbot in a particular chat window, everything said in that conversation is going to be remembered in perfect detail by the AI. But if you start a second chat window, it's only going to have a very sparse summary of what was said in the previous conversation. And this is very unlike a human. I think when you're having a conversation with a human, you'll definitely remember a little bit more about things that were said very recently, like within the same conversation, but not perfectly. Even within one conversation, especially if it goes on for a little while, you might start to forget what was discussed at the beginning. And conversely, if you're thinking about something that was said 2 months ago, you'll still have some memory of it, right? You won't have forgotten about it completely, or the extent to which you remember it will be much richer than just remembering like a specific, like one sentence summary of what was discussed. You might even remember a particular turn of phrase that was used or a particular anecdote that was shared. And so it's sort of these two sides of the difference, right? In the immediate conversation, the AI remembers much more than you might expect from a human. But that conversation is also much shorter than a typical conversation with a human would be. And beyond that, the AI is going to remember much less. And this is really a consequence of the fundamental technology behind how these things are built and how they choose basically what to respond when you say something to them in a conversation.
Yeah, and so how is it different? How is AI memory maybe different from other computer memory in terms of what it can remember and what it can't remember? Is there a difference there as well?
Yeah, the typical memory that happens on a computer is memorizing basically bits. It's a particular
Yeah.
set of bits that you can write anything to and read anything off of. And it's always going to sit there and sort of like remain in that form forever. Now, the AI that you talk to, like ChatGPT or something, is going to have one form of memory that's very similar to this. And this is what's called the context or the KV cache, which are often used interchangeably. The KV cache basically represents everything that the neural network has produced during this conversation about everything leading up in the conversation to here so far. And this is the part that feels more perfect, feels more like photographic memory, and feels more like typical memory on a computer. And indeed, like the KV cache is stored in memory on the computer, just like any other file could be stored. But when you go beyond a conversation, now the information that's sort of like carried over from the past does not get carried over via the KV cache. Instead, it gets carried over via natural language, like a sentence in English, for example. And this is very different from how other memory on the computer works, because you're actually only able to convey ideas that can be expressed concisely in natural language. And this is the secret of how it works, actually, is that in a second conversation, the first thing that the AI reads from you in that conversation, in some sense, is notes on your last conversation or on your previous conversational history. And that's
So it
it.
doesn't
That's
go back
the
word for word. It doesn't go back word for word and look at everything that you've ever typed in, that you've asked before, right?
No, nothing close. And in fact,
Yeah.
the predictions that it makes, the responses that it makes, are completely unaffected by virtually everything that you've ever typed to it in the past. But it does write these little summaries, just a few sentences long or a few paragraphs long, that it it takes notes on you before starting the next conversation. And then after finishing a conversation, it takes notes on you, and then it reads those notes at the start of the next conversation. But that's it. Other than that, you're a blank slate. In some ways, I would analogize this to visiting maybe a consultant or a medical professional, somebody who is constantly seeing patients, for example, sees so many patients that they barely remember anything about a particular patient. And when you walk in the next day, even though you visited them a year ago, so much time has passed and so many things have gone down, they don't remember you. They don't remember what happened, but they have their notes. And they took a few notes after the last visit that they review before you walk in the room. And so they're in some sense prepared. And this is basically
right there or they review it right there in front of you.
Right there. While you wait. Exactly.
And so you were saying, I'm sorry, I interrupted. So so they're just reviewing what they've already, done before. And I think when we talked before the show, I think I asked you about the different, like with humans, they have short-term, long-term memory. And a lot of people understand that short-term memory will eventually go, for humans, it goes away. And then it really only, I would say, unique things get stored into your long-term memory. But this is not the same thing with AI. It's more like, the workings of the brain are different than just someone taking notes, like your doctor example.
Right. I think the human short-term, long-term memory, it's true in humans that there are some things that can be only remembered for brief times and things get stored in for longer. Psychologists and neuroscientists have a lot to say about that, of course. But actually, I think in this case, it's a little bit confusing because the short-term and long-term memory, they really are on some level part of the same unified system, right? You're always just remembering stuff. And sure, some stuff you forget quickly, some stuff you remember for a long time, but even stuff that goes into your long-term memory eventually gets forgotten, right? When enough time has elapsed. And some stuff that you might expect to be in your short-term memory maybe can still be recalled like a long while later, right? So in humans, even though there is some amount of short and long-termness going on, it really feels very unified. And in AI systems, it very much does not. There are two completely different mechanisms by which the past can affect the future. And it's the two things I just mentioned. Either the immediate conversation, which lives in the KV cache and can be recalled in perfect detail, and every single detail of the current conversation affects the response, or it's the note-taking system for things farther back in the past, where only the very high-level one-sentence description of what went on conveys any information at all to affect the current prediction. It's like, have you seen the movie Memento? Are you familiar? Old Christopher Nolan movie?
Yep.
So for listeners who have seen Memento,
let's get a quick summary. Yeah.
Yeah.
It's from your long-term memory. Give me the summary.
It's a thriller about a man with a particular sort of mental condition. And the movie is told in an interesting series. It's jumping forwards in time and backwards in time with all these cuts to try to put you in the shoes of the protagonist. And the condition that he has is he basically only has short-term memory. So anything longer than 5 minutes ago, he completely forgets. But this man is on a mission. I'm not going to spoil anything by getting into exactly what he is trying to accomplish or whether he's successful at it. But let's just say this mental condition that he has is a big handicap. He really struggles staying on task to accomplish his overall objective because he keeps forgetting what he was trying to do in the first place. And the way that he remembers, the way he tries to keep himself on track, is he writes himself little notes. Post-it notes, he tattoos the most important things onto his body, but he basically communicates with his future self via natural language, summaries of the place he was at after, doing a little task. And this is basically exactly how current AI systems work. And this is why, while in a single conversation, they can be incredibly impressive, do just like really, really amazing feats that previously were only accessible to humans. In a long-term conversation, or basically like an ongoing relationship, they really leave something to be desired, current systems, because they just aren't able to sort of like synthesize over a long period of time the knowledge that they would need to keep sort of like building out that relationship.
All right, so as we're going forward, how does this then create problems for people that are using AI? Because again, most people right now, I think they're just usually just looking, they're asking a question and getting an answer, so it feels more like they're using it as a search engine. So is that good enough for them right now? And then where do we start seeing problems where this current method of memory is not going to be good? We're going to almost end up like the character from Memento.
Yeah, I think right now the reason people are using it this way is because that's what works, right? It's sort of a chicken and egg
Sure.
thing going on here.
Yeah.
And I've seen people sort of try to use it in the other ways, realize it doesn't work, and fall back to using it in this way instead. So yeah, I think like that current sort of setup of just treat it like a consultant, ask it a question, get an answer, move on with your life, come back to it another day, ask it another question, get another answer. Perfectly useful, right? Like it's obviously a huge value add to a ton of people right now. But the future possibility is to have AI that can actually execute a task over a long period of time independently. And this basically requires the AI having the ability to stay on track, stay like focused on its objective over a long period of time without forgetting or getting confused. And right now, because the short-term memory of the AI is so expensive, you can only have so much of it. And because the long-term memory of the AI is so bad, once you exit the short-term memory and go into the long-term memory, you lose track, you fall off task. So people, I think, for example, in the domain of software engineering, which, as a AI researcher, I interact with all the time,
Yeah.
there's real excitement around AI being integrated into code editors for software engineering and AI agents, which can then autonomously execute like little subtasks of the coding problem themselves. And I think the tooling for example, auto-completing in the code editor is very good. The tooling for making a request out to an AI and having a little snippet of code sent back to you is also quite good. But the more complex your request becomes, the less and less useful it is. And we are still not yet at the point where you can, for example, say, hey, here is a bug in this large software project, and I want you to go and work until you've solved the bug and made sure that all the tests pass, and then get back to me and tell me what you did and what the fix is. This is something that you might want to basically like use in order to augment your workflow as a software engineer, right? That way you don't have to spend your own time solving every single little bug. Lots of times, like an error will be flagged that's not something core to the project. And so you'll basically sort of like downgrade it as a less important thing to move on. It would be great if you could instead just delegate an AI agent to solve this issue. And right now, there's just a limit to the complexity of issues that can be accomplished. And I feel a very large part of this is the ability of the AI to stay on task, continually trying to solve that bug until it's resolved over many, many sort of iterations.
Is this also related to the issue of hallucinations, where at some point, if it can't, or are they two different parts of the AI equation? I feel like if an AI agent couldn't necessarily solve the problem, it would then somehow go to default and go, oh, well, here's the problem, and just make up stuff. Or am I just assuming that it would go to the hallucination? Where do they fit
I
in?
think so. My opinion on hallucinations is that hallucinations are not special as an error category. A hallucination is just a name for an error that an AI makes that confuses a human, right? Like sometimes the AI makes an error and the human is like, no, that's like clearly wrong, right? For example, if it
Yeah.
outputs gibberish or if it outputs the wrong language in its response, you're like, okay, no. But sometimes it outputs an error that looks plausible to a human. They eyeball it. They're like, yeah, that seems right. And they maybe continue. And that's what we call hallucinations. But there's nothing special about hallucinations as an error category. So really the question is, why do AIs make errors, right? Like, how do we make them make less errors? And one part of this that has been, pushed to its like extreme already and continues to be pushed every day by a lot of major AI labs is within the current sort of way of building AIs, there's this notion of the scale of the AI. And you'll hear about this talked maybe like how many flops went into its training, floating point operations, basically like how many CPU or GPU cycles went into its training. Sometimes you'll hear about this talked as parameter counts, either the total number of parameters or the number of active parameters, which is the number of parameters that essentially get used per request. So lots of different metrics here. These are all ways to increase the intelligence of the AI and thereby decrease the likelihood of hallucinations. But one way that's very important, that is much more similar to how a human sort of like increases their own intelligence in the sense of makes themselves more likely to come up with a good answer. A human does research, right? If you ask a human, hey, quick, like tell me right now, who was the 23rd president of the United States? They're probably going to hallucinate. I mean, unless they're a history buff, right? I know exactly who that was.
I mean, I was just going to say Martin Van Buren, and that was just a name I threw out. I'm probably wrong.
Yeah, but like maybe, right? Sounds plausible to me. I don't know who the 23rd president of the United States was, but I know where to find that information, right? And that's what's crucial. And for a simple lookup like that, actually, already in current AI systems, you'll see they'll be like, oh, like, you know, like searching on the internet. There's like deep research, these sorts of things. If you ask an AI this question, it'll probably check Wikipedia and get back to you with the right answer. In other words, it won't hallucinate. But what about a much more complex question? A question where the answer can't just be quickly looked up on Wikipedia with a simple search. What if it's an answer where the answer requires like many steps of search through all different parts of the internet, really trying to like track down one piece of information or even synthesize something out of many pieces of information? Now, at this point, you go back to the same problem of needing to stay on task for a long period of time. In order to complete the search task, it's not enough to just do like a one-off thing and reply. You have to like keep going, read each source, understand it, maybe reread an old source that now is different in context since you've incorporated some new information, and eventually get to the right answer. And that process is going to require the same long-term memory that everything else does. Like right now, again, like if an agent attempts it, it is able to store some amount of that information in its short-term memory. And then after that, it's forced to just take notes about things that it's seen before.
Yeah.
In a very non-human-like way. So,
during your answer, I typed it in and I got Benjamin Harrison. So I was wrong. So he was the, good
so
thing you didn't say like if you said first, I would have been able to say.
Well, exactly. But 23rd, that one, I think you got, like first you'll be correct. 23rd, you'll hallucinate.
Right. So I wanted to ask, like, what so with an acknowledgement of this problem, correct? I mean, do most researchers feel like that this is a problem? Like, I think and then the second half of the question is like, what risks are we now creating as we're moving towards agentic AI and maybe trust in some of these tools, both personal and for business?
I think virtually every AI researcher has the goal. Well, I mean, there's like capabilities researchers and safety researchers who maybe distinguish themselves here. But at least people who are interested in pushing the frontier of intelligence would view their goal as making the AI produce wrong answers less, which in my view is a form of decreasing hallucinations, right? Like any effort to that extent will also decrease hallucinations. Now, I think that the strategy that I'm describing, basically what I view as the biggest bottleneck to increasing intelligence, which is the ability to stay on task for a long enough period of time, relative to where we're currently at. This wasn't always the biggest bottleneck, but relative to where the field is currently at, this is what I view as the biggest bottleneck. I think not every researcher shares that view exactly. Lots of people are pushing in lots of different directions. But I think virtually every researcher would agree that, yes, this is one of the problems. Like this is one of the main axes by which we can improve the quality of the responses. And this is an axis where there is still lots and lots of open room to do better. As far as building trust goes, I basically view the process of delegating to an AI as, or like in an ideal world, being akin to the process of delegating to a human. And when you have a new employee, you don't immediately delegate the most important tasks to them. And you also don't immediately trust when they get back to you with their results that it's going to be something good, right? Like you might say to the intern, like, hey, like prepare my slides for this important presentation. But you're going to look at those slides before giving the presentation, right? Like you're not just going to go for it. Now,
Right.
if it's been 2 years and now you like really trust them, they're deeply involved in the project and you've seen them pull off good stuff lots of times before. Now maybe instead of like looking at those slides the day before, you'll just look at those slides the morning of and confirm, right? So it's just like this process of building trust between two humans. I think something very similar is going to ultimately be the solution to deciding when in a business or personal context to delegate to an AI. This is something, again, that I feel like people are getting wrong right now because they sort of anthropomorphize too much, but it actually goes even beyond that. People who use ChatGPT often view it as some like super intelligent arbiter of decisions, right? Some judgment on high. I've seen lots of people. I don't know.
It's absolute truth, whatever it says, right?
Exactly. It's like if ChatGPT says it, it must be true. I've seen people actually a very amusing way to resolve like roommate disputes, for example, amongst college students.
Wow.
Just like both people make their case, put it into ChatGPT, and have it make the judgment. This is actually something I've seen people do. It works better. It works better than you'd think, right? And maybe not because it's always correct, but sometimes you just want to resolve things in some way.
Yeah, I mean, I guess if you could if you think that it's a neutral party, right?
Yeah,
or third
exactly.
party.
And it feels neutral. It feels sort of like it has this breadth of knowledge that you can't easily access elsewhere. And so it feels like you should trust it. And I think this sort of gives people false confidence in many ways and inspires them to trust it a little bit more than they should. They should treat it as, no, this is just like any old person off the street who needs to earn my trust in this domain. They need to prove themselves as being a good decision maker in this type of decision, or very knowledgeable about this topic or that topic before I'm willing to trust them further. And I think this is something that maybe you can't like require of people in their personal lives, but I do think it's something that is going to evolve into a business best practice. You don't just like swap in AI because it's AI and expect it to be better. Instead, you like carefully swap in, like you probationarily swap in the AI, see how it does, and if it does well, then move forward with it, you know? And I think that's just the only way to solve this issue in the long run.
Can you talk about what companies like OpenAI and maybe Anthropic and others are doing to try to address? Are they just basically bolting memory onto the existing transformers? And, you know, is that the correct path, or do they have to kind of reassess, almost come up with a new way of thinking about how to fix this problem?
So based on my knowledge of what researchers at OpenAI, Anthropic, places like this are doing, the main focus is on pushing the limits of the current paradigm. So essentially, there's two ways to give the current set of AI agents like better memory. One way is to make the very good short-term memory cheaper. So the cheaper it is, the more effectively you can extend it longer and longer. You basically have more tokens of short-term memory. And when people talk about context windows, this is what they mean. So when, for example, like Google Gemini comes and says we have a 1 million token context window, what they mean is they've extended their short-term memory to 1 million tokens. And so tokens basically correspond to like size of input. And so they expect to be able to do sort of like short-term memory quality recollection over that horizon. Now, these claims are not always perfectly well-founded. In practice, I think when external third parties evaluate these various models, typically the actual most effective context lengths are much shorter than the reported context lengths. Often it'll be like, 1/4, 1/3 of the actual like reported number that you get best performance on, and beyond there, you're less effective at using each new piece of context in general. This is something that I think is dependent a lot on the specific like data and task as well. So it's not always easy to put a specific number on what length of context is actually being used effectively. But these are just the ballparks that researchers have, independent third-party researchers have identified. And that's one side of things. The second side of things is let's think more about how to use the long-term memory. And everyone here is basically using it's sometimes called a scratch pad approach, where you're essentially summarizing past conversations and using that as a prompt at the start of the new conversation. And there's lots of different ways to do this, like different heuristics for how to effectively turn to summarize basically a conversation into some text, which summaries to keep and which ones to discard as things go longer and longer. And this is all like a very active area of research that I know is going on a lot at these big labs to try to improve their ability to retain information beyond that context length threshold, beyond the short-term memory. I don't think that either of these solutions are the right one. My view is that fundamentally, the technology needs to change. And this is actually what I work on in my own research at Manifest AI.
Right.
Transformer.
And you call that power retention, right? That's the terminology you're using?
Yes. Power retention is a particular architectural layer. So transformers is sort of the architectural backbone of all current AI. Transformers were first introduced with this paper called Attention is All You Need. And attention is, in this case, a technical term referring to a particular mathematical operation for how to incorporate information from the past into the current prediction. And this goes on the short-term piece, they basically had to turn your context into a prediction. And attention is what we view as the major bottleneck for extending the context lengths longer and longer. And the reason is that AI using attention to process its context is more or less equivalent to a human that has photographic memory, perfect photographic memory. And this might seem like a good thing. Like everyone wishes they had better memory, right? But if you think about what it actually entails to have photographic memory, you realize that it just makes every single aspect of your life completely impossibly slow to think about. Imagine being a doctor, with a 60-year career, undergrad, med school, seen a bunch of patients, and now a new patient walks in. And now in order to make that diagnosis, you have to replay 60 years of your life just to give them a response, right? Like you sit there for 2 hours, just like in a fugue state, just like muddling together all the details of what happened. It's just not tractable. Like that's not how useful doctors behave. It's not how humans behave, right? No human really truly has photographic memory over their entire life. Instead, humans forget. Humans forget unimportant things and remember important things. The way to view what a human memory is doing, in some sense, is as compression. You're taking every experience that you've had and compressing them into this fixed size brain that sits in your skull. And every time you're reacting to something, you're using all of the things that you've seen in your life to some extent, but not in perfect photographic detail. Can you recall them? And this is how retention is designed. Our architecture power retention is essentially taking all the good parts of attention, the computational, basically the computational properties, like the hardware efficiency, the ability to ingest and scale to massive scales, but bringing in this new piece of remembering only the things that matter. The idea of retention is you can retain the important pieces. So whereas attention needs to remember everything to attend to all of it, retention just retains the parts that are going to be useful to be attended to in the future. And it's all trained completely end-to-end via gradient descent, just like the rest of the neural network. So there's no sort of like external pieces, no extra knobs that need to be like bells and whistles that need to be added. It's just this one piece, power retention, that swaps in for attention. And now you have an architecture that can actually scale what in transformers is the short-term memory all the way out to the whole experience that this AI has ever had.
Okay, so I'm just going to take your word for it that this is great because I like you, Jacob. So if we have this system, I would assume that one of your first benefits is that it becomes less expensive, or you're able to scale at less cost than what you would currently do if we're on that other path. But also, then what are some of the other benefits that you get out of utilizing a power retention architecture versus like what are we going to then benefit from this?
The main benefit is that you're actually able to use really long contexts. They're able to take what is currently just a short-term but very powerful memory and use that same mechanism over extremely long sequences. So all these things that I described before about, for example, how agents have a tough time staying on task because once the task gets complex enough that they're forced to switch from their short-term memory to their long-term memory, they lose focus. This goes away when you use retention, which allows you to use the same powerful memory across the entire trajectory, no matter how long or complex the task is. And this does, at the end of the day, come down to cost primarily. Ultimately, everything in AI is about like intelligence per dollar, right? The miracle of deep learning, the breakthrough that basically enabled this latest and greatest wave of AI progress, is the fact that every single dollar that you spend training current AI improves its intelligence, no matter how many dollars that is. And it's actually something that we didn't have 10 years ago, or like at least we didn't know that this was possible, that you just have this like basically unending funnel of like you can just pour more and more compute into it and get more and more intelligent AIs out as a result. So now that we have that, the main unlock to stronger AI is intelligence per dollar, right? It's cost efficiency. And as I was saying earlier, I think one of the main underexploited ways to make our systems more intelligent is to give them more information, give them access to more information that they can use to complete tasks better, give smarter responses, hallucinate less, like, understand the implications of the question more. And this is something that our architecture unlocks, is the ability to leverage this context at a much cheaper price. And, current architectures can leverage it, but it's just way too expensive. So nobody does. So you don't get as much, grounded. Your prediction is much less grounded in external reality, because feeding that external reality in is very expensive and forces you to fall out of the strong short-term memory and into the bad long-term memory.
Okay, and can this approach, does this work with any type of process that people are using with AI? For example, in the early days, we would talk about people using AI for accuracy focused tasks, but then it could also do creative type of tasks. Draw me a picture of this, or write me a poem, or write me a joke. So does this approach work in both of those processes, or is this strictly for more accurate answers, less hallucinations? Is there a creative approach to this, or does a creative approach not even need the type of memory that we're talking about with some of these accuracy type things?
Yeah, that's a great question. I feel the creative processes do benefit from similar ideas in a lot of ways. So one example of this might be if you want to iterate on some creative work. If you right now use any like chatbot and ask it to generate you a picture, it will. But you're not always happy with that. Sometimes you ask it for changes to the picture. And sometimes it'll give those changes. Yeah, you always want, right? There's always something off. And you can do a handful of changes, 3, 4 changes, 5 changes, whatever. But at some point, it might start remaking mistakes that it already fixed in an earlier version. And at some point, if you have enough...
that part irritates me. Like, I'll have it draw something like I'm doing a flyer, and then all of a sudden, after I ask it to make one fix, it inserts an error in another part of the picture. And, especially when you're with the text part, like it inserts typos when I don't want it to.
Yeah. And I think this is, in many ways, a product of this same thing, over a long enough period of time, it will start to forget to have trouble making use of things that sort of were presented to it a very long time ago.
Right.
And it seems like right now, AI are able to help with creative tasks and give good responses. In the same way that it seems like right now, for example, in the coding domain, AIs are able to give very good responses to individual, very tightly constrained coding questions. But you can't just ask an AI to, fix this bug and let it go wild and do whatever it wants and expect it to come back to you with something good. And similarly for creative domains, I think if you have a much more complicated, like creative project, something that would require many steps of iteration and only then come back to you with a response when it's sure that it's good, it'll also be unable to do that. For example, you might imagine that the AI is going to like put out some flyer or something, right? And you want it to be a flyer that is maximally appealing, right? And so you might want the AI to come up with a couple drafts of flyers, run its own A/B tests as it compares different versions of the flyers and gets feedback from various people and iterates on the flyers until it comes out with one that it's certain is good and conveys the exact right messaging and also gets all the details right and has no typos, etc. And this is something that right now is not possible. It could be a valuable part of a workflow of a human doing that, right? Like when you're designing a flyer, you could use the AI to keep giving you sort of like new modified versions of it in response to you're going out and basically managing the long-term structure, the long-term goal. If you're focused on the long-term goal, AI can be a useful step in that process. But what this changes is that the AI itself will be able to have the long-term goals and drive toward it of its own accord. It'll still probably, if an important piece of this is checking with you for feedback that the flyer is good, then that's something the AI can and will do. So it's not like it'll just go completely off on its own and go haywire and come back with something that you don't expect. But the process of driving towards the ultimate vision is something that right now you are forced to manage, essentially. And that can be moved eventually into the AI as well with this technology.
Do you think that this, with a couple of different approaches to the technology, that we're going to end up in like a VHS Betamax, and that was for the old people on the podcast, or a Blu-ray versus HD DVD? I think those were the last times we've had a technology battle. I guess Google versus iOS, you could say, in the mobile phone space. Like, is it going to be one or the other, or will both be able to achieve different results, or does the whole industry have to move towards this in order to get past that next bar that everyone's facing when it comes to memory?
Because AI software is so sort of like hardware flexible, I don't think that there's going to be nearly as big of a switching cost as opposed to something like Blu-ray versus VHS, where you need to like physically manufacture and buy an entire different piece of hardware to put on your living room TV or whatever.
Okay.
So I do think there's going to be a little bit of a battle. For example, like there's platforms like vLLM, which is a inference platform. So that means that anybody who has trained an AI model and wants to serve it with like high throughput to a large number of customers uses this piece of software to do so. And that piece of software currently supports the current paradigm very, very well, right? Like it's able to serve transformer models, which are attention based, very fast and very efficiently, and has lots of sort of optimizations in there for that. And our models, which are trained with power retention instead of attention, are not as well supported. Except obviously, like that's what we do, right? Like we write the kernels that enable it to be supported. But that's just like one example. And there's lots of different things that are like this, where basically new support will have to be added for this new family of models. And to the extent that people are hesitant to use a model that doesn't have broad support, and people who are hesitant to support a model that they aren't yet sure is going to be the right architecture, the architecture that's eventually going to win, to the extent that that happened, there might be a bit of a battle between these two. And I think something that I'm excited to see over the next year or two is whenever a big new model gets trained, when architecture details are released, which they aren't always, but when architecture details are released, it's always very interesting to see what architecture choices they made, because that sort of like gives some signal as to what direction the field is going. And I think they're going to be battling it out for the next couple of years, attention versus power retention, to see which is the one that's actually going to be the backbone of the next generation of AI models from 2026 on. And I am very, very bullish that power retention is going to, it's the underdog right now.
Okay,
Transformers
well,
are
you kind of have to be. You kind of have to be, Jacob.
I suppose
this is what your company's working on. Yeah. All right. So I'm going to use my powers of my short-term memory to call back what we were talking about at the beginning of the show. And I figured since you brought it up, there might be a good answer here. If the character from Memento had ChatGPT in its both current and possibly future form, or an AI tool. I won't say ChatGPT. I'll say like as an AI, an AI tool. Would the film end differently, or could you do a remake with an AI tool but it wouldn't be as interesting, I guess. It would be my prediction. But
I think,
how would this story have changed?
yeah, I think in its future form, the form that I hope to see these AI systems possess within the next couple years, I think the movie would go very differently. It's interesting because right now, when you think about the relationship between a human, for example, a human software engineer and the AI assistant, or similar to what I was saying, the example of like if you want to design a flyer with the AI there, same thing. The high level structure, the long term vision, the cohesive goal orientedness is accomplished by the human. Now, any individual step might be accomplished by the AI, but driving toward the mission, that's the role of the human. Because humans are good at that. But one human isn't good at that, and it's the protagonist from Memento.
Mm-hmm.
So, in that situation, if he had the AI of the future, now the AIs of the future that I imagine are themselves capable of this long-term, goal-oriented planning and operation. If you gave him that AI, then the roles would be reversed. The long-term goal, the coherence of the sort of like the things that he's figuring out and the objective he's trying to accomplish would be stored in the AI itself. And the AI would be telling him what to do. It would basically, the AI would be using the protagonist of Memento in a similar way to a current human would be using an AI, in that it's something that can accomplish short-term goals very effectively, but needs guidance on the broader mission. And so, yeah, I think that film would go very, very differently.
But that doesn't make it for an entertaining movie, right?
Well, I'm no Christopher Nolan, but I think he could figure out how to make it entertaining.
Yeah, so now what I'm going to have to do is I'm going to have to go rewatch Memento, because again, it's been such a long time. I only remember certain bits from the movie, kind of the beginning, like what you explained, and then I think I remember what happens at the end, but now I forgot. So, see how we've come full circle here? This is great.
Yeah, you got to refresh your memory with the.
There you go. Jacob Buckman again from Manifest AI. Thank you so much for being on the show. I had a blast, and I'd love to have you back in the future as we see more and more developments in the memory field for AI. So thank you.
It's been an absolute pleasure. Thanks so much for having me.
All right, that's going to do it for this week's show. Be sure to like the video, subscribe to the channel, add any thoughts you have below if you're watching us on YouTube. Join us every week for new episodes of Today in Tech. I'm Keith Shaw. Thanks for watching.